Okay, so this should be a quick video just going over something that you've gone over countless times since elementary school: mean, median, and mode. So mean, median, and mode are all different kinds of averages. Excuse me. Mean is the one you're most familiar with. Typically, if somebody says average, then you assume mean unless they specify something else. So mean is the sum of the values in a data set. Data set divided by the number of values. Now remember, sum is addition. So you're going to want to use the mean when, let's change our color here, when the data is fairly close together. Otherwise, you'll see that some data points can really change the value of your mean, and they can change the meaning of your information. Now, the median is the middle, the middle value when the data is arranged from least to greatest. You'll want to use your median. It gives us a lot of useful information use it when we have an outlier. One or more outliers in our data. Outlier is a data point. It's a piece of information that doesn't quite fit with all of the other data points. Finally, the last kind of average that we're going over today is the mode. So the mode is the value that occurs the most often. The value that occurs the most often. Now, note that not all data sets will have a mode, because some data sets don't have any repeated numbers. A value set with no repeated numbers would have no mode, and additionally, you could have a data set that has more than one mode if they are tied for the most often. Now we're going to start just with an example here. We'll calculate the mean, median, and the mode for all of the numbers below. We'll start off with the mean. Remember, the mean is the sum of our values divided by the number of values. So our sum would be equals 5 plus 9 plus 11 plus 11 plus 18 plus 21 plus 21. That's our sum. The mean isn't just the sum. The mean is the sum divided by the number of values. So divided by number of values, we'll count them. 1, 2, 3, 4, 5, 6, 7. There's 7 values. Perfect. So the sum of my numbers here, let's see, I have 5 and 9 and 11. The sum is 96. If I put that into my calculator, I'm still dividing that by 7. So 96 divided by 7 is 13.7. So note, the mean does not have to be a whole number. It can be a decimal. It can be a decimal or a fraction. So our mean is 13.7. Let's try our median. Remember, our median is the middle value if it's arranged from least to greatest. So we can see that our numbers are already arranged from least to greatest. What we'll do is we'll start crossing them off and find out what's left at the end. So we'll cross out the first and last, and then the next and next last, and we'll cancel from the outside in, leaving us with only one number at the end. That is 11. Our median is 11. And our mode is the value that occurs the most often. I'm going to erase those scratches there. So our mode occurs the most often. Well, we'll notice our data set, 5 only occurs once, 9 only occurs once, but 11 occurs twice, 18 occurs once, and 21 occurs twice. So our mode is 11 and 21. We have two different modes here, so really we should have an S there. Modes, 11 and 21. We can accomplish the same thing for example 2. I'll let you calculate your mean, median, mode for example 2 on your own. And then we're going to look at the effects of outliers. So again, an outlier is a data point that doesn't fit in with your data. Sometimes an outlier can come because there was an error collecting your data, or because something shouldn't belong there where it is. So let's compare the median for set A and the median for set B. Sorry, the mean and the median for set A and B. So we'll start off and find the mean of set A equals 17 plus 19 plus 23 plus 24 plus 35, all divided by 1, 2, 3, 4, 5 of them. So divided by 5, and let's see. That's 118. Oops, divided by 5. 118 divided by 5, which is 23.6. Okay, so that's our mean of A. We'll find the mean of B. Equals 17 plus 19 plus 23 plus 24 plus 81. Okay, so we see right now when I write out all of those numbers, the only difference in our data sets in set A and set B is in set A I had 35 here, in set B I had 81. So if we're giving a little bit of backstory, we could say maybe that set B had an error on the final data set, on the final point, and we had the number 81, but it should have been 35. So we'll see how that one error can change our means here. So we still have, let's see here, so our mean, we still have 5 data points. We'll divide by nice round 5 there. And let's put that into our calculator. 17 plus 19 plus 23 plus 24 plus 81 is 164 this time. Divided by 5, bringing us a mean of 32.8. So we can see that this mean here for the data set of B is actually bigger than every single number in there other than the last one. So this as an average might not give us very much information, whereas this mean over here fits fairly evenly right within the middle of the data set. Now if I look at our medians, for set A, I'll cross off the first and last, second and second last, I'm left with 23. So B, I'll cross off our first and last, second and second last, and again I'm left with 23. So our medians are the same. So we'll find, if we calculate our means and medians for many of our data sets, if we do have an outlier in our data, the median can actually still leave us with an accurate representation for an average of our data, whereas the mean is it is a little more accurate in general, but it's very susceptible to being messed with. If there's just one error in the data, then it can throw our mean completely out of whack. So this should give you the information. Again, this all should be review, but hopefully that review makes us feel a little bit more comfortable with means, medians, and modes, 3 types of average.